Right here we have an open top glass aquarium with a square base that is designed to hold 62.5 cubic feet of water. What is the minimum possible exterior surface area of the aquarium? Now, the fact that the aquarium is open topped is very important, okay? So it's got a bottom to it and it's got four sides, okay? But it doesn't have a top. So it's got the bottom. And then it's got 1, 2, 3, 4 sides. So here's what we need to do. Now they tell you it's got a square base. All right, so I'm going to call this side X, and I'm going to call this side X. And then the height I'm going to call H. Now it says it's an open top glass aquarium with a square base, and its volume is what?
62.5.
Very good. Its volume is 62.5 cubic feet of water. So they tell you the volume, but they want you to minimize the what? The surface area. So what we need to do is we need to extract a formula for the surface area of this aquarium. Okay? So the area of the base, I'm going to call the surface area S. The area of the base would be what? So the area of the base is X times X, which is X squared. And then what we've got to do is we got to add to that the surface area of each of the four sides. Okay? Now, this height is the same. That's H, this is H, and this height in the back's H. So this side will be X times H, and so will all the sides. So you've got four sides times XH. And so what I did in this formula here is I derived the surface area formula of the cube. Okay, and now the volume formula, what would the volume formula of this cube be? Length times width times height, that's correct. Length times width times height. But in this case, the length and the width are the same, aren't they? So it'd be X squared times what? H. Okay. The problem with this formula is it's in terms of two different variables, X squared and H. All right? So they tell us the volume. What is it? 62.5. So I'm going to plug it in for V right there. 62.5 equals X squared H. And then what I'm going to do is I'm going to take this equation and solve it for H, right? And once I have it solved for H, I'm going to plug what that equals in for H in the surface area equation, which will benefit us because then the surface area equation will be all in terms of X instead of two variables, X and H. So if I were to solve the volume formula right here for H, what would I do to get H by itself?
Divide by squared.
Good. Divide X squared on both sides. And so I have H equals 62.5 divided by X squared. Now, I know that what's inside this blue box that I'm drawing is what H equals. So I'm going to take and I'm going to plug it in for H right there. And the only reason I'm doing all that is so that my surface area formula is in terms of how many variables? One variable. So I've got that the surface area equals X squared plus 4X times H, which is 62.5 over X squared. So now I have a surface area formula that's all in terms of a single variable, X. Okay? And so now all that's left to do is to minimize the surface area formula. Right? So I'm going to find the first derivative. I'm going to calculate the critical numbers, and whichever one is a minimum, that's my minimum X value that gives you the surface area, the minimum surface area. All right, so now we know that this formula represents the surface area all in one variable. So I'm going to take the derivative of it. S prime equals 2x. Okay. Now what I should have done before I took the derivative was I should have multiplied this 4x on top right here. Okay. So let's go back. Let's take our surface area formula, and I've got x squared, and I'm going to take this 4x right here, and I'm going to multiply it on top. So tell me what 4 times 62.5 is.
250.
So I've got plus, it's 250 even? 250x over x squared. And then what you notice is that this x right here cancels with one of these x's here. And so your true surface area formula is x squared plus 250 over what? X. So let's keep finding the derivative. So the derivative of x squared was 2x. And now I need to take the derivative of 250 over x. Okay, I'm going to rewrite 250 over x as 250 times x to the negative 1 power. Now, negative 1 times 250 is negative 250 x to the negative 2 power, right? So my derivative is s prime equals 2x minus 250 over x squared. So I now have the derivative, okay? Now our critical numbers are where the derivative equals 0 or where the derivative is undefined, right? So the most obvious critical number is 0 because that's what will make this denominator equal to 0, okay? So we have one critical number at x equals 0, and now I need to take that equation and I need to solve it, okay? To solve it, here's what I'm going to do. I'm going to multiply both terms by x squared first. And the reason I'm doing that is I'm trying to get rid of the what? The denominator, right? So I'm going to multiply the x squared here, and I'm going to multiply the x squared here. Now when I do that, I get s prime equals 2x cubed minus 250 because the x squareds cancel, right? And so now I'm going to take my derivative, 2x cubed minus 250, and I'm going to set it equal to 0 so I can see where the slope of the tangent line equals 0, because then I'm guaranteed either a max or a min. So I'll add 250 on both sides, and I'm not guaranteed a max or min. There's a high likelihood of a max or min. And so I've got 2x cubed equals 250. And so to keep solving, I'm going to divide 2 on both sides. And so I have x cubed equals 125. And then I'll take the cubed root of both sides.
You get x equals 5.
X equals 5. And so I have two critical numbers, 5 and 0, right? And so what I need to test is I need to test 0 and I need to test 5. Now tell me what our derivative was. I can't remember. The original derivative. S prime equals 2, was it 2x?
Minus 250 over x.
Okay, so here's our derivative. And what we want to test is something to the left of 0. So we want to test f prime of negative 1. And we want to test f prime of 1 and f prime of 6. Now we're testing to the left of 0 to see if the function's going up or down. Okay? So when we plug negative 1 into the derivative, you'd have a negative 2 and here a positive 1, but that'd be negative. So the whole thing would be what? It'd be negative. So the function's going down to the left of what? 0. Okay, so now we're plugging 1, and I should have written, I missed my prime symbol right there. It's important to write your symbol so you know where you're plugging. I'm plugging into the derivative. So f prime of 1, that's positive 2, but that would be negative 250, so it's also going to be negative. So at 0, we don't have a max or min, do we? Okay. Now let's plug in 6. Okay? 6 squared is 36. So right here I'd have 2 times 6 is 12 minus 250 over 36. What is 250 over 36? Okay, so it's positive, so it's going back up, right? And so right here it's convenient that I have a minimum at 5. Okay, and so what we're saying is that my x should be 5 on my box. So the base of my box should be 5 in both directions. So we got that x is 5. And so this side right here should be 5. And this side right here should be 5, right? But we still don't know what the height is. And remember, this wanted us to tell what the dimensions would be of the box. Okay? So if this side's 5 and this side's 5, what I can do is I can go ahead and plug 5 in for x where? Right here, right? And so I've got 62.5 equals 5 squared, which is 25, right? Or, remember we devised our formula for our height? Here's our formula for our height, right? All I'd have to do is plug 5 here. So what is 62.5 divided by 25? So my height is going to be 2.5. And so my dimensions are, my length is 2.5. My length is 5. My width is 5. And my height is 2.5. And with these dimensions, what we did was we minimized the possible surface area of the equation, of the aquarium. And so you can see right here the question, but see, we still hadn't answered the question. What is the minimum possible exterior surface area of the aquarium? So we need to tell what the surface area is. So what I'm going to do is I'm going to take 5 and plug it in for x here. And I'm going to take 5 and plug it in for x here. And in this h, I'm going to plug what? 2.5. And so you've got 25 plus 4 times 5 times 2.5, which I think is 75. So our minimum surface area is 75 cubic what? No, it wouldn't be cubic feet. Surface area would be what? Yeah, feet squared. And so that's your answer. The question asks, what is the minimum possible exterior surface area of the equation? The minimum surface area is going to be 75. That's the very smallest you could make it.